Glad to be here. Thank you.
Yep.
Can everyone hear me okay? Yeah? It's the wrong question to ask. Can anyone not hear me? Also the wrong question to ask. They wouldn't know to answer. I'm very glad to be here. Thank you, Bert, for that introduction. Thanks to Cal and Kathy and all the others who kind of helped get me here today. I really enjoyed yesterday and all the different interactions and conversations and activities we had. It was a lot of fun, and I learned a few things along the way too, which was really exciting. I liked how we kind of got to some insights through a variety of activities. We're going to do a few activities here in this kind of keynote session, and then we'll have a short break, and then we'll have a kind of more robust activity after that I'll direct you. So that's a little preview of the next little bit. Let's see, my location, Derek Bruff. You can go to derekbruff.org. That's my website. I've actually posted my visuals for this talk up there right now. So if you go to derekbruff.org and click on presentations, you should see it right at the top of the screen. You're welcome to follow along now or just check it later. You'll see as we go, I've got a lot of links to more information about particular ideas and examples. So if you want to follow those links later, you can just pull up the Prezi from my website. I will also say that I'm really active on Twitter, @DerekBruff. Had fun yesterday at the Twitter back channel at this very conference. Several of you were very active as well. Feel free to tweet during my talk here today. Just try to say nice things. I do want to remind you of the hashtag, which is #LDSC15. So if you can use that, that'll help us find your tweets. Let's see, a bit of an introduction here. So I direct the Center for Teaching at Vanderbilt University. I consider myself kind of primarily in the faculty development or educational development world. Not quite what instructional designers do, but it's pretty close. I think a lot about faculty. I think a lot about students too and how they learn and how faculty can help students learn. But I think a lot about faculty, particularly when it comes to educational technology, because if I want to help faculty teach more effectively or more efficiently, as Bert mentioned, you got to know the technology, but you also kind of have to know how faculty think about their teaching and what's going to help them take a few new steps in how they approach their teaching. And so trying to kind of get into the faculty mindset is a big part of my job. And so what I want to do today is to try to use a bit of that lens and try to kind of go out into the future of educational technology just a little bit here. And I've used this metaphor of leading lines. So I am a amateur photographer. I got into photography 4 or 5 years ago. Actually, I mentioned this to a few people yesterday. I read Gar Reynolds' book, Presentation Zen, which is it just opened my mind to a whole new way to use slides in PowerPoint. Very strongly visual. I got so interested in finding cool images on Flickr to use, I decided I wanted to learn how to take cool images myself. So I got into photography, and one of the ideas you learn about fairly quickly in photography is this idea of a leading line. Right? If you've taken art classes, this is in other kind of visual media as well. The idea is, and I took this yesterday actually as I was out for a run, so this is actual Pennsylvania corn right there. The idea is you've got these kind of lines that are formed geometrically in the image, and they lead your eye into the image, right? This one's pretty straightforward. This is kind of a nice geometric, one line at the top, one line at the bottom. Others are more complicated. They can curve, right? The idea, though, is that you've got this kind of line that's guiding you into something. And I want us to kind of think about what are the leading lines that are helping us figure out what the future of educational technology might be. So what I'm going to do is I'm going to look at a few different kind of categories of technologies that I think are kind of a few considerations here. I'm big fans of these in general. I think they work well to foster student learning. I think there's a lot going on behind these technologies pedagogically. I think they're also ones that are relatively broadly adopted by faculty. So this is kind of the faculty development mindset. Like, what are the things I see faculty doing, right? And where might they go? Where might they want to go next that would help them do the kinds of things they want to in their courses? And so what we're going to do is we're going to look at the kind of recent past and the present and then try to say, well, what if we could say, where's this kind of category of technology going next? What would we want it to be, right? And so that's kind of where we're going today. A few caveats first, 3 in fact. As Kyle talked about yesterday, I don't know that I want to predict the future. I'm pretty bad at that. I was even bad at predicting the results of the brackets yesterday. Like, let's not predict, let's invent, okay? So we're thinking not what's going to happen, but what do we want to happen with educational technology, okay? The other caveat is that this is not a comprehensive list. I'm not going to talk about wearable technology. Kyle, sorry. But there's other stuff out there that's really interesting, right? I've just picked a few that I kind of know enough about to kind of go somewhere. So this is not comprehensive. The third one is related to this. So have you seen Rogers' diffusion of innovation model? Does this look familiar to folks, right? So the idea is that if you have a particular innovation, then someone kind of comes up with it. There's a few people in that category. If it seems to kind of have some legs, then some early adopters will jump in and get it. Then there's this kind of chasm where the majority of folks might adopt it. And then Rogers calls these the laggards. That seems a little offensive. We'll just say they're fine where they are, right? These are the folks who don't adopt the innovation. And I've used this as kind of a lens to think about faculty, right? So if I think about a particular technology, a particular educational technology, there are some instructors who are kind of coming up with it. There are some who jump on the bandwagon pretty quick. And then there's a big majority who may or may not. I mean, that gap there is a little wider intentionally. Rogers calls that the chasm, right? There may be a lot of faculty who never adopt a particular technology. And my point in sharing, well, these folks definitely not, but even the majority might not really get there. And my point is this, I'll borrow from William Gibson, the future is not very evenly distributed, right? So what is future to some faculty member may be present to some other instructor, right? And so my example of this, and I'll talk a little bit about teaching with clickers, because that's one of the things I know a lot about. Just last year, I went into a department at Vanderbilt and did my kind of Clickers 101 workshop, because the faculty in that department were just now interested in learning what clickers might do for them, right? I've been giving a version of that workshop for 10 years now, right? It's not innovative, it's not cutting edge, it's like bread and butter technology as far as I'm concerned, but for those faculty, it was innovative, it was the future, all right? So I want to kind of put that out there to kind of modulate. There's kind of things that we might see as kind of way out there that may be like decades out there for other faculty. So the future is not evenly distributed. Okay, so enough with the caveats. I am, on a talk of the future of higher education, I am bound by law to show you this image. 14th century, higher education, right? This is pre-printing press. And so this is pretty sophisticated technology, right? There's one book. Some dude is reading from the book. Other people are writing down what he is saying, because that is the most efficient way to copy a manuscript, right? That's, okay. So I am also bound by law to compare this image to today's classroom, right? Which often looks a lot like that, right? So I don't want to go into too much. I actually don't think this is as true as people like to make it out to be, and we'll kind of unpack that a little bit. But again, the future is not evenly distributed, right? There are a lot of classrooms that look a lot like this, that seem to have that same kind of basic copy down function. So let's go to the future, all right? Surely in the future, classrooms don't look like this. And so I don't have any Back to the Future clips. I have a few clips from other things that kind of give us a vision of the future. And so here's where I see if I can get the sound to work.
The savage outer planets were not so enlightened and refused alliance control. The war was devastating. But the alliance's victory over the independence ensured a safer universe. And now everyone can enjoy the comfort and enlightenment of true civilization.
Oh, man. Look at that. Holographic projector and everything. Still, one teacher at the front of the room, students in desks pointing in that direction, copying down notes, right? This is from the 2005 movie Serenity, written and directed by Joss Whedon. It's a fantastic movie, but I don't really appreciate his vision of the future of education, right? This looks just like that 14th century picture, but with slightly fancier visual presentation tools, right? So this worries me a little bit. But I would assert that we can indeed invent the future of higher education. And I want to share an example from the recent past that demonstrates this. So this is a video. I'm going to show you a little short clip from a video that was put together in, I think it was 2007, might have been 2008, at Abilene Christian University. And you need a little bit of context for this video, okay? Abilene Christian University in Texas had decided to go essentially all in on the iPhone, right? And this is 2007, right? At the time, I think maybe 10% of their students had a smartphone, right? It was a very small number back then. The iPhone was still fairly new. Their plan was to give the incoming group of first-year undergraduates iPhones as part of tuition. right? So all students would have an iPhone. Technically, it was an iPhone if they paid for the data plan. If they didn't want to do that, they could get an iPod Touch, right? But the idea was that every student would have one of these smart devices in their hands. So to go from maybe 10% of students to 100% of students, all the first years, and then we're going to roll it out over time, right? Now, what I thought was really fascinating about this, because I was kind of tracking this, I thought this was pretty interesting. What happened at Abilene was really a vision of the future, right? We are now at a point where on our campuses, something like 90 to 100% of students, it's not 100, but 90 to 98% of students have at least a cell phone, if not a smartphone, right? So mobile devices are prevalent in a way that they weren't back then. But Abilene was going to jump that and just give away smartphones to give a sense, what would campus be like if everyone had one of these devices? The really clever thing they did was George Saltzman, the director of their teaching center, was teaching a course that year on educational technology. He had his group of students brainstorm what campus would be like next year when everyone has an iPhone. And they put together a video to kind of show this vision to the rest of campus so they could understand what campus might be like once everyone has an iPhone. So I want to show you just a minute or two of this video to give you a sense of what they envisioned.
And use it as you study for the course. Great.
As you're finishing that up, we want to get a sense of what you know about the modern period. So a survey will be coming to your
That did not work.
iPhone. Go ahead.
Okay. Let me open it again and see if I have better luck. If I had a hologram projector, this probably wouldn't have been a problem. Someone get on that. There we go, that looks better. So that's what you missed. I'm going to take it up to right around, I don't have the time code, let me try this. Well, it looked promising. Okay, well, I'm going to scrap that. Oh, it's catching up. Count of 5. There we go. So now we have video and no sound. That's fantastic. That is absolutely fantastic. Okay. Well, I did say it was a vision of the future, so I'll play the role of Bill Rankin there, okay? He's an English professor. This is a mock classroom we're seeing on this video. All the students have iPhones. It's a class on the modern period, so he's asking them to kind of generate examples of modernist stuff from art, from literature, from other areas, from history. Right now, actually, so our lead character, the young woman there in the blue, mentioned a Cubist exhibit that she saw at the art gallery. And she says, I think I can pull it up on the exhibition guide. And so Bill Rankin says, great, go ahead and add it to our list of links. And now all the students are contributing links around modernist ideas and examples to this kind of shared RSS feed here that's at the front of the room. You can kind of see it over there. Now they've kind of changed the activity a little bit, and they've said, we sent a survey to your phones. We want you to just kind of type in examples of modernists, modern things from art, from history, and from literature. And so on the right, you're seeing this kind of word cloud pop up as students are kind of submitting their answers, right? And so the more frequently an answer is submitted, the larger the font size there on the word cloud. And then he does a little bit where he kind of uses the word cloud to kind of guide class discussion after that. So sorry, Bill, you've got a really soothing voice, but we didn't get to hear it today. The thing that I love about this is, so there was like versions of, social bookmarking websites that were out there at the time. This idea of doing live class response with free text answers that auto-generated a word cloud, no one had done that until George Saltzman and his students imagined that would be a useful classroom app. It took a few years. They developed their own version of this, a live working, this is just a mock-up here for the video. But the next year, they developed an app that actually did that, right? And now, if you look at any classroom response system where students bring their own devices, if it's worth its salt, it has a word cloud visualization tool, right? Kind of an automatic thing. This is fairly standard practice now in the classroom response system realm. And it was envisioned by these people trying to imagine what would it be like if everyone had an iPhone in their hands during class, right? So they invented their future in this example. I think we can do that too. One day I'm going to teach a class like George's class, where I'm just going to get a bunch of students and we're going to imagine what the next thing could be and we're going to build something and envision it. It's just so exciting. So sorry for the technical difficulties. Let me return to the Prezi. So with apologies to Joss Whedon, we can do better than Serenity, right? We can imagine a future that is more than just what we did in the 14th century. So let's do a little bit of this together, okay? So like I said, I'm going to talk about kind of 4 categories of educational technology. I'm going to start with the one that I know the best, which is clickers, classroom response systems. This is the idea that, and I won't walk you through this question. I do that a lot in my sessions on clickers, but I want us to do a few different other things today. This is a question, though, I ask in my own mathematics class. I teach a course on probability and statistics occasionally. And when we start the unit on probability, I want my students to confront a particular misconception they have. And so I put this question on the board, and they all have clickers, some kind of handheld device in their hand, right, where they can respond A, B, C, or D. And when they do, I get a bar graph at the front of the screen that shows the distribution of answers, right? That's the basic technology. It's been robust since 2005, right? This is kind of technology, like I say, that's been around for a good 10 years. Does anyone use clickers? Raise your hand if you've used clickers in some capacity. Okay, most of you are at least a little bit familiar with this. A word about how I use this question. This is what I would say, call a misconception question. So the question says, your sister calls to say she's having twins. Which of the following is more likely? Assume she's not having having identical twins. Is it more likely that she has twin boys, twin girls, or one boy and one girl? Or are all 3 of those equally likely? Now, like I said, if this had been a workshop on clickers, I'd have you actually work through this, just like I have my students do it. But I'll cut to the chase here. A lot of people answer all 3 of these are equally likely. Usually the distribution is kind of split between options C and D the first time I ask this question. And that's true of my undergraduate students. That's true of rooms full of faculty. It's usually split between these 2 answers, right? So what I have them do, I have everyone kind of think about it and vote, and we see the bar graph, and they're usually split between C and D, and then I say, okay, turn to your neighbor. Talk this question out. Put your heads together. See if you can come up with the right answer. If you both agree already, talk it out anyway, because you could both be wrong, right? And so then I give them a few minutes in their pairs to talk it out and try to kind of justify their reasoning to each other. And then we vote with the clickers again, all right? And then we get a bar graph a second time. Now often, not always, but often, the second bar graph shows some convergence to the correct answer, which is it's not B, C, actually. So mathematically speaking, right, you got 2 twins. The first one is either a boy or a girl with 50-50 odds. We're making some simplifying assumptions there, but we'll go with that, right? The second one is a boy or a girl with 50-50 odds. So you have 4 equally likely outcomes: boy, 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 girl, girl, boy, girl, girl. So as a mathematician would think about this, there's a 25% chance of twin boys, a 25% chance of twin girls, and a 50% chance of one boy and one girl, all right? Again, in class, we do this tree diagram and talk it out and all this kind of stuff. The point here, though, is that a lot of people have this misconception that these are all equally likely, all right? When you flip a coin, when you roll a die, when you pick a card out of a deck, right, all the options are equally likely. So we tend to think probability must kind of work that way. There is an equally likely element to this, but you really have to model the situation carefully. And when you take that boy, girl, girl, boy, and kind of mush them into one event, right, then you've got to account for that in your probability model. So this misconception that everything's always equally likely, students have to confront this misconception on day 1 of our unit on probability, or they are out of luck for the rest of the unit. right? So I do this through this clicker question. In fact, we then modeled this. I have them all flip a coin or a clicker or whatever they have that they can flip, and they flip it twice to simulate having 2 children. It's the crudest birth simulation ever, right? Flip a coin. Hey, that's what it's like to have a kid. And then I asked them to report their votes. How many of you got 2 girls? How many of you got 2 boys? How many of you got 1 of each, right? And then the data kind of roughly fits that 25, 25, 50 model. So they're fairly well convinced at that point. So I want to talk a little bit more about the process here in a minute, but I feel like after Anne's talk yesterday, I have to offer some kind of justification, some defense of the multiple choice question. I think this is a beautiful multiple choice question. I'm a little biased, I wrote it myself, but it's beautiful. It specifically targets the misconception that I want to resolve in my students' heads, right? There's a wrong answer that is specifically targeting this particular misconception. Now, on some level, is this a great test question? Yeah, it's a pretty good test question, I think, right? Students still have a 25% chance of getting it right, even if they know nothing, right? But it's still not a bad test question. I don't use this as a test question. I use this in class, right, with the clickers to get students to really grapple with this misconception, right? It's the multiple choice format that frames and structures our conversations in class, both small group and large group. You can do a lot with a good multiple choice question. You can do application questions. So I just have 3 quick question examples, just again, because you can do a lot. This is from Patrick Lynn. He teaches astronomy at Cuesta College. Here's what the night sky looks like now. Which of the following best describes the positions of these constellations 24 hours later? Right? This is a straight up the middle application question. Do you understand how the rotation of the Earth affects kind of how we view constellations? Right? There's a single correct answer to this. I think this is a fine question. It's a fine test question, I think, targeting that kind of application skill level. This is a terrible test question, I think, but as a clicker question, it's really fantastic. So this is from Wes Drips. He's an earth and environmental scientist. He's a hydrologist named Dr. Drips. He's a great guy, too. He's at my alma mater, Furman University. And so he asked this question several times during his course on climate change, right? And he uses clickers, right? Scientists don't really know if the climate is changing. Do you agree or disagree, right? This needs to be an anonymous response kind of question for students to answer honestly, but he needs to know how his students are feeling about this, right? And he may ask this several times during the semester to get a sense of kind of how they're changing based on the evidence that they're looking at in class. This is a really helpful multiple choice question. This one's a little crazy, but I love it. This is from Elizabeth Cullingford, who teaches English at UT Austin. She teaches a large literature class. She'll have 150 students in the room. They'll do Shakespeare together, right? This is a bit of a challenging teaching environment. So what she'll do, this is one of her questions. She'll put up a passage from Hamlet, right? Stuff that Hamlet says right after Ophelia dies. Spoiler alert, sorry. And so there's this quote from Hamlet, right? And then she says, what's he thinking, right? What's his motivation in what he says right here? Is it that he really loved Ophelia and is so distraught to learn of her death that he proposes to eat a crocodile, something he says in the passage? Is it because he thinks Laertes' grief is mere posturing and he mocks it by exaggeration? Or is it that he cares little for Ophelia but is eager to enter a rhetorical chest-thumping competition with her brother? What's his motivation here? And so she has her students vote on this, right? And then she'll have a few volunteers say, well, here's why I think Hamlet is saying this, right? And it's always about what does the text say, right? Look to the text. Draw on evidence from the text. Defend your position using evidence from the text. This is critical thinking. This is important kind of reasoning skills that she's having them develop. What she likes to do, one of the things that's a bit artificial here, this is a weird multiple choice. This is a terrible test question. Terrible test question. Because all 3 of those answers are completely defensible, according to Elizabeth, right? Hamlet's motivations at any given point in the play, she tells me, are kind of up for grabs, right? It's about making the case for an argument. How do you use the text to argue for one of these? That's what she wants to get her students to do. This could be an essay question on a test, right? Where students pick one of these and then defend it. But in class, it's designed to structure those conversations, right? And to get students to the end. She'll often pick whichever of these gets the fewest votes and then kind of make the argument for that herself, kind of devil's advocate style, to help students kind of understand how this works. So a small defense of multiple choice questions. With clickers, you can do a lot with multiple choice. Let's talk a little bit about process here, okay? And then I've got a clicker question for you of sorts. So this is what I just described, what I do. It's called peer instruction. Eric Mazur, I think, was here recently. He talked about this process as well. It's a pretty standard way of using clickers in the classroom. Pose a question, have students vote on their own, right? Then, depending on the results, ideally you have them, they're split and they pair up and talk about it, right? And then you move on to a second vote and a class discussion. If for some reason most of them are correct, right? If 95% of them get them right, you might not want to do that peer instruction phase. You might want to just say a few words and kind of wrap it up and move on. If most of them have it wrong, right? If 90% of them get it wrong, having them talk about it in pairs is probably not going to be very productive, right? You've got to do something else at that point. This is the structure. So here's my question for you. How does this sequence of activities help foster student learning? And what I want you to do, we're going to skip the solo vote here. I want you to find a partner, okay? Groups of 2 or 3 for this. I want you to talk for a few minutes about what kind of teaching and learning principles are at play here that help foster student learning. Why? How might this sequence of activities help foster student learning? And then I'm going to ask you to report your results, your ideas, using Poll Everywhere. So I'll say more about this in a minute here. So I don't have clickers to pass out to you, and clickers don't do free response very well, right? But whatever mobile device you have in your small group, right, you can probably respond to this. So quick check. Raise your hand if you have a device on your person that can either hit the web or send a text message. I think that's 100%, all right? So you need someone like that in your small group to report your group's answer, okay? When you're ready as a group, either go to pollev.com/Derek Bruff and type your answers in right there. All you need is a web browser. Or if you'd like to do the text message route, you text to 22333. That's what you put in the to field. It's only 5 digits, but it'll work. Text, this is your initial message, just my name, right? And that'll kind of link you up, and then you'll have more instructions for actually submitting your answer to this question, all right? So talk about the question. How does the peer instruction sequence help foster student learning? Come up with a couple of ideas, and then report them via Poll Everywhere. Go. So here are your responses. So I'm seeing a lot kind of reflection, right? Having to articulate your own thoughts and reason. Think, pair, share, right? You got to do a little bit on your own, and then you have a little kind of safe spot to talk it out with someone else before you have to contribute to the big discussion. Gives me a chance to drink some coffee. I had green tea, but yeah. Different mental models, right? Kind of activating prior knowledge, helping students kind of grapple with their own existing mental models. Immediate feedback, that's a big deal as well. Active learning, yes. Lowers the stakes on failure, less pressure on the individual student, absolutely, right? You get a chance to be wrong a few times without anyone having to know, which as we saw yesterday was really important. Students need to stop searching scores in airline fares, yes. Shoe shopping, that seems to come up a lot in these discussions of classroom distractions. Yeah. There was, I was down there somewhere, and I can scroll back. Diversity of opinions, actually, particularly, not so much with even with the multiple choice questions. You can kind of get minority opinions coming out if you've crafted your answer choices well, but particularly in the free response questions, you can get some interesting perspectives that you might not have predicted, right, or that might not be majority opinions. I wanted to a couple of things about the platform before we talk about the pedagogy again. So this is called Poll Everywhere. It's one of my favorite systems like this to use. There are others, Learning Catalytics, Top Hat, Lecture Tools. They're all pretty good. Poll Everywhere is free for up to 40 responses per question for educators. And so this is really helpful, right? Our foreign language instructors at Vanderbilt use it all the time. They never have more than like 12 students in their classrooms, right? So it's just a great tool for them. It has a few different question types that I can show you. Hi, Mom. See, I will say I stopped showing you the responses as soon as I saw the joke about coffee, right? because for two reasons. One, I didn't want people to start showboating by getting their funny thoughts on the big screen. The coffee thing was funny, right? But that could get out of control. The other, more fundamentally, was I wanted you to have a chance to think about your own answers before you saw what everyone else said, right? This is a key part of this process. Now, I mentioned word clouds earlier. You can word cloud this. That will be a little weird for this type of question, right? Because it's going to break up all of your sentences into individual words. I'm just going to show it to you. If the question asked for a list of words or like one or two words to describe something, then the word cloud tool becomes much more helpful. So let's see if we can, let's see, I think I need to go, is it here? Yeah. So this is the word cloud version of your answers. It's taken all those individual words, it's grouped them together. The more frequently they popped up, the bigger they are, right? So students, thinking, learning, think, peers, gives, right? Those are some of the major ideas there. But then there's, reflect, coffee, learners, social, right? The little words are important too, right? Especially coffee. Okay, so I wanted to share, you guys hit on most of this, I wanted to share a few kind of ways I think about some of the key benefits of this process. And here's where the leading lines comes in, okay? So for each of these technologies, I want to share a few key principles that make them work. And I want us to think, as we invent the future, we need to preserve those principles, right? The learning principles that make a technology work and be effective, right? That's what we need to keep as we advance that technology and make it do new things. So here are three key principles I see in terms of clickers and classroom response systems. One is this idea of formative assessment, okay? My visual metaphor for that is an X-ray of a laptop. And if you want to know what's inside of a laptop, you need to do something to look inside, right? X-ray, screwdriver, hammer, whatever you want to do, right? In a similar way, if you want to know what your students are thinking, right, what's going on in their heads, how they're learning, what misconceptions they have, you have to do something to try to make that more visible, right? And clicker questions do a good job of identifying particularly student misconceptions, but also just different perspectives students have, different ways of reasoning, and making that more visible. We call that formative assessment, right? This is distinct from summative assessment. That's the thumbs up, thumbs down evaluation that happens at the end of a learning process, right? This is formative. This is meant to provide information to the student so they get some feedback on what they're learning, and meant to provide information to the instructor so the instructor can make good teaching choices and be more responsive to the student learning needs. And what I love about clickers is that it allows you to do that on the fly, live during class. And by class here, I know a lot of you work with instructors who teach online. Really what this works in is synchronous learning experiences, right? You don't have to be in the same place to use polling systems like this. In fact, polling systems were around long before clickers in online environments, right? Clickers just allowed us to do it in a physical face-to-face kind of way. But this idea of being responsive in the moment to how your students are thinking and what confusions they have, there are a few folks in physics education who call this Agile Teaching, right? Now, this is not me. I don't do that. I have run off-road a few times with my feet, not on a bicycle. But imagine what this guy's having to do, right? He knows how to ride a bike. He knows what hills are in general, in the abstract. But he's got to respond to the immediate situations as he's going down this hill, right? He's got some skills he can bring to that, but he's got to adapt on the fly to the context that he's in. And so Agile Teaching is the idea that you're going to adapt to your particular students' learning needs on the fly, right, as you learn about them. Ian Beattie and the other physics education researchers who coined this term contrast it with what they call ballistic teaching. That's when you launch a lesson plan at the beginning of class and nothing can interfere with its trajectory, right? We don't need that, right? We need Agile Teaching. So formative assessment, Agile Teaching, and then I'm glad someone hit on this because I think this is important. So I want to talk about diversity here just for a second, okay? And this is a really complicated topic, and I'm just going to hit one highlight, really. It's really deep. And in the visual metaphor I'm about to share, hats represent students, okay? So imagine you're not using clickers. You've got a bunch of students in the classroom. You throw out a question about, I don't know, climate change, right? And you ask for students to put their hands up and respond, right? You're going to hear from that student over there, right? You're going to hear from that student over there maybe, and maybe that third student as well. You're not going to hear from the rest of the students. And you may have noticed the students that raised their hands were all purple hats, right? That doesn't always happen, but that happens a lot, right? The students who are going to put their hand up and speak out in class, they're not always representative of everyone in the room, right? And so you've got perhaps a lot of other perspectives and opinions about something that you may not be hearing at all. And classroom response systems can, if used well, highlight some of those different perspectives and use that to strengthen the conversations and the learning that's happening in class. Using a diversity of opinions as a strength for learning. Again, we can talk more over the break about how hard this can be to do well, but it is something that I think that is a great potential of these systems. Now, leading lines. Okay, I said clickers have been around since 2005. These days, we have bring your own device classroom response systems. Okay, this was one of the reasons I put BYOD like in the finals in the brackets yesterday, right? Like I think there's a lot of power, right? So this, where's my phone? It's over here. This little thing. Okay, did you watch the Pluto flyby this week? Was that the most awesome thing ever? Well, at least this month, right? This phone, right, this little thing has more computing power than the computers that sent astronauts to the moon in the 1960s. Plus, I have the freaking internet, and they didn't have that either, right? Surely we can think of something useful to do with these things in class, right? Surely that's possible. And Poll Everywhere is my favorite tool, right? But there are others, as I said. And what these tools do is they open us up beyond the multiple choice question paradigm, right? As useful as that is, we can now do free response questions, right? We can do place mark questions where people get an image on their device and they point to an image, a place on that image, and you see it. We'll do this in a few minutes. I'm going to have you guys practice this. And then the Poll Everywhere has this kind of voting thing where people can submit answers and then vote other people's answers up or down. It's great for kind of Q&A and prioritizing questions that students have. I love this realm of educational technology because what it's doing is it's kind of opening up the classroom to all types of active learning. And it scales up really well. You can have 200 students in the room and still kind of manage classroom using these types of tools. Where might these go, right? Leading lines. Where are we going next with these types of tools? Where would we like them to go? I'm going to show you another video here. Fingers crossed. This is from Minerva. Have you heard of Minerva University? This is that kind of startup that wants to be the new Ivy, and they don't have a physical location. They like send students around the world for different cities each semester, and it's all kind of online, virtual, seminar-style classrooms. They have a little video where they imagine what that's going to look like. So this is their version of the future. I want you to look for the classroom response systems in this video. Oh, right, this is the one I have to switch over to the web. That one did not embed correctly. Let me exit out of that. Go there, hit play. Internet. Everyone, please turn off your Wi-Fi so I can have it. I think this was your Back to the Future problem. There's no Ethernet connection up here, is there? Ah, seriously? Coming through for me. All right, well, I gotta bail. So imagine with me, if you will, what was that mindset thing about these like discs in plastic cases in the attic that no one can use anymore? There's some reliability in a DVD player. I need to upgrade to that new technology. So a couple of the things they do, they have this kind of virtual seminar thing where all the students are on essentially webcam kind of stuff, right? And they're all kind of looking at each other in like that Brady Bunch style, Google Hangout style thing. They have a couple of tools they've added to that. And so they can do polling in that environment, and there's this nice kind of pie chart that pops up to show how the students have answered the poll, and you see the little students' faces like in a cluster next to an answer so you know who said what, right? Which in a seminar is actually really useful, actually. You might not want that anonymity. You might want to be able to say, I want to call on that student because they picked C. The other thing that they imagine is a student debate, two students, like their two big heads up front talking to each other, debating an issue. The other students are voting on the student's arguments. So you see this little bar graph, this little line graph at the bottom that's kind of going up and down as the other students say, yeah, that's a good point, right? That's really interesting stuff, right? We're close to having that kind of stuff in the classroom. Here's my imagined future, okay? So I'm actually going to have you guys do a little bit of this here in a minute after the break. And so I wanted to show you what it's like to doodle the future, okay? So I whipped this out pretty quickly in my hotel room the other night because I've been thinking about this idea for a little while. But so imagine, right? I've got some images of some sort. Maybe it's an art history class, maybe it's a geology class, maybe it's a biology class. I want to send a collection of images out to my students' devices. I want them to work in groups to tag those images, to give them kind of keywords to describe them against kind of various heuristics that we're looking at. Then I want to have a word cloud on the big screen under each image so that we can talk about it as a group, right? That's what I want. There's no tool that does that. We should build that tool. That's awesome, right? Send the images to students. Students tag them, show up as word clouds, right? Maybe some kind of drag and drop thing, right? So I can move the images around and pick the ones that I want. Maybe student-created images. Maybe the students do something and then send it in, and then I collect those images and I pick 5 and I send them back out to the students for them to analyze and annotate and tag, right? Wouldn't that be awesome? Maybe mapping pins instead of tags, right? Identifying areas and images. Crowdsourced annotations, right? Like, I want tools that do this. And you know what? I want tools that let instructors come up with their own question type to fit the need of that particular class session. That's the future I want to invent for classroom response systems. I spent, 4 years trying to convince one of the clicker systems that they should kind of move in to do something like this. And they didn't want to make it, right? Like, we should build this. We can build this. We need like an open source WordPress kind of version of classroom response systems so we can hack it and make it do the kinds of questions that we want to do. Okay, so I'm mindful of the time. I've got 3 more technologies to talk about. So I'm going to move on to number 2 here. This was the one I wanted to drill down a lot because there's a lot of really good learning principles here. Let's talk about adaptive learning systems, all right? So we had the Khan Academy. Actually, these are all screenshots from 2001. I'm kind of doing some leading lines here. Recent past, present, and where we might go, right? 2001, Khan Academy hits it big, right? What do they have? They have these really cool videos that are generally mathematically accurate, generally. There's a couple of math faculty at Grand Valley State University who have this kind of funny web series. Remember Mystery Science Theater 3000 where the people are in the front row making fun of really bad B movies, right? They did that with Khan Academy math videos where they point out mathematical flaws that Salman Khan makes during his videos. It was a little snarky and a lot of fun. So generally good videos, right? Questions, answers, feedback, right? All kinds of dashboards and statistics. Students can see those dashboards. Instructors can see those dashboards. This kind of knowledge map kind of thing where all these different concepts and ideas are connected and build on each other, right? They've mapped all that out. Khan was doing that in 2011, right? It's even more sophisticated at the Khan Academy site now. The videos are certainly a little better. But now, I saw a presentation last year from Acrobatic, right? This is a spinoff from Carnegie Mellon, the online learning initiative. They do this, it's just fantastic, right? They have this kind of skills graph where they've mapped out in that knowledge map style kind of exactly how all the skills are related to each other, how they build on each other. It's all focused on learning objectives. There's this beautiful alignment between objectives and assessment and activities through the whole system. All types of different question types where students get immediate feedback on their answers and can practice and practice and practice, right? Different dashboards for students and instructors so you can kind of get a sense of where you are or where your students are. This stuff's getting good, guys. This is good, okay? So the Carnegie Mellon did some studies of the use of this software in a statistics class. And the results were so positive that Ithaca, the research division, did a randomized control group study at 6 public universities. And this was statistics again. They found that the hybrid model, OLI, right, which was the Carnegie version of this software, and 1 class session a week versus the traditional model, 3 to 4 class sessions per week, essentially identical learning outcomes, right? That's pretty significant. At Carnegie Mellon, they actually found that the hybrid folks finished the course in half the time, right? Like, this is big. This adaptive learning stuff is starting to work, right? You probably have faculty who use some version of this. I know our science faculty have kind of online homework systems they use that do versions of this. This stuff is getting really good. So why does it work? Well, people need practice and feedback if they're going to learn something, right? This we know from how learning works, right? This little dude's going to fall down a lot. Every time he falls down, his body's going to learn a little bit about not falling down, right? He's got a helmet. He's got the knee pads. He's safe as safe goes, right? He's got a safe environment to practice, but he needs that feedback to get better, right? As we learn, physical, mental skills both have this quality. We need practice and feedback on that practice. Mental models we talked about earlier, right? A lot of these systems really understand the mental models, the misconceptions that students have. So this is my example. I was in London last year, and I took this photo, right? So I don't know if you know, but in London, they drive on the wrong side of the road, okay? They don't call it wrong, right? As a pedestrian, right, when I come to the road, I need to look right, because that's where the oncoming traffic is. As an American, I look left. That's my mental model of how traffic works, right? Not a wrong mental model, right? It's just not the one that is helpful in this situation. I've got to readjust my mental model. Luckily, Central London has these nice little reminders. They're like, oh, look right so you don't die, right? It saved my life many, many times, right? I've got to adjust my mental model, right? And often our students need to adjust their mental models to more accurate ones, more robust ones, more contextually appropriate ones. And these systems often do a good job of doing that. And then knowledge organizations. We know this too, right? We've got to connect those ideas in our heads in various ways. We need meaningful, robust connections across those ideas if we're going to use those ideas to solve problems, right, and do interesting things. And what I like about some of the really good adaptive learning systems is they've mapped out some of those knowledge organizations, right? They know how these ideas connect and apply and relate to each other, and they can help students develop those knowledge organizations as well. Okay, everyone cross your fingers. I'm going to pull up the internet again. We got another vision of the future. I think you'll recognize this guy.
Computer, resume testing.
Who said logic is the cement of our civilization with which we ascend and we cast you use it as our guide?
Keep 1.5, matron of local philosophy.
What is the molecular formula of human stuff like crystals? Right queen to section 5, grid 6, queen takes knight, rook takes queen, white pawn to section 5, grid 7, pawn takes rook. Checkmate. What's significant reference to the bioengineering being able to carry out quotes on Clinton?
The universal atmospheric element compensator.
Evaluate complete. Extraction sensors indicate is being pursued so closely that it not specifies space pursuer. Identify object and its cultural significance.
Klingon mummification glyph.
What was the King's vertical business manager in the year 1987? What was Kirk Bob's first law of metaphysics?
Nothing unreal exists.
Correct. Adjust the sine wave of this magnetic envelope so that antineutrons can pass through it and antigravitons do not. What is the electronic configuration of gallium? How do you feel? How do you feel? How do you feel?
I'm going to stop right there. We're not going to talk about the how do you feel question, all right? That's a whole other can of worms. Adaptive learning, right? Right? So I saw this clip years ago. This is Star Trek IV, the one with the whales, right? Came out in 1986. One of the best Star Trek movies. Really, all the even-numbered Star Trek movies are great. The odd ones, you can just skip them all. Your pro tip for the day. I saw this years ago, and actually, I want to give credit to Tim Stelzer, one of the iClicker folks, for this idea, right? If you look at the kinds of questions that Spock is being asked here, right? He has died, right? That was Star Trek II. Then he came back. That was Star Trek III. And in Star Trek IV, he's being tested to kind of see if he's still got it, right? But let's think about the kinds of questions this computer was asking him to show that he's still one of the most brilliant people around, all right? And I actually want you guys to analyze a few of these questions, all right? So get your mobile devices back out. We're going back to Poll Everywhere. All right. So, you know Bloom's taxonomy? Bert mentioned this earlier, all right? If you don't know what Bloom's taxonomy is, ask your neighbor, all right, as you work through this question. I want you to pair up again. This is a multiple choice question. This was one of the questions that was asked of Spock. Who said, logic is the cement of our civilization with which we ascend from chaos using reason as our guide? In case you need to know, the answer is this particular Vulcan philosopher, okay? But what I want you to do is to take this question and classify it according to Bloom's taxonomy, all right? Is this a create question, an evaluate question, an analyze question, an apply question, an understand question, or a remember question? All right? So talk to your partners, come to some consensus, and vote. Go. So one note, I will say, Pullover will let you have the bar chart move live. Again, I didn't want to show you each other's votes as you were thinking about it, right? I wanted you to have the chance to kind of weigh in independently. Now that could totally change as people like go with the popular or rebel or whatever. I can also lock down the vote so it stops, right? I'm not going to do that. I think most of you are right. I would put this in the remember category, right? I'm actually not going to ask for justifications in the others because the next couple of questions get a little more complicated. This was the softball, right? Spock needs to remember who said this, right? He doesn't even have to know what that sentence means to know who said that, right? So I think this is at the lower end of Bloom's taxonomy, all right? See, number 45 agrees with me. What about this one? Let me activate this. Oh, it is active. Let me hide your results. All right, same thing, new question. Adjust the sine wave of this magnetic envelope so that antineutrons can pass through it, but antigravitons cannot. That was the little sine wave thing that Spock did, okay? What category question is this? Go. Last call. All right. High degree of consensus on this one as well, all right? Take what you know about sine waves and magnetic envelopes and antineutrons. I think these are mostly made up. Well, sine waves are real. I don't know about the rest of them, right? Now, some of you went for analyze. Why might you think of this as an analyze level question? Yeah?
Depends on the nature of the simulation. If it's a simulation, or if it's a
I like that. If you're having to kind of respond to kind of new input as you go, then there's probably more than a couple of ideas at play here, right? And you'd have to understand the relationships among maybe 3 or 4 different variables. Yeah, I like that. If it's just kind of a word problem in a textbook, right, maybe not. Maybe that's just kind of a straight-up application question. Yeah. It's always a little hard to know, right, when you're doing Bloom's taxonomy. You got to know context a little bit, right? This could be a memorization question for all we know, right? Someone told Spock the answer yesterday. He just had to remember it, right? Oh, when it's this, you do that, right? He may not understand anything here. But it's probably meant as an application question or something close to that. All right? I've got one more Spock question for you here. All right. This was a little trickier. Evaluate and conclude. A starship's sensors indicate it is being pursued so closely that it occupies the same space as its pursuer. The correct answer here that Spock gives is that the warp drive regulators are creating a parallax matter echo. You know, one of those. All right? So, how would you categorize this question via Bloom's? Go. Last call. I know. Oh, lordy, lordy. We are all over the map here. So let's take them in order. Someone defends evaluate. Fitz. Right. Why might this be an evaluate question? Because it says evaluate in the question title, right? Clearly not everyone agrees with that assessment. Yeah.
I thought it was evaluate because the idea is he's just getting measurements from sensors, and assuming it doesn't give an error code, he's having to deduce, oh wait, my warp drive regulator is creating a parallax matter echo.
Okay.
It's not that we're really being pursued because otherwise we have visual.
Oh, sure, right. There's like a false information here. Okay, so like, is this information true, right? Can we depend on this? That elevates it to evaluate for you, okay? What about analyze? That was number 2 in the list. Why might it be an analyze question? Yeah?
Analyze, there's no decision that he has to make as a result of this.
Okay.
So it didn't make it into the evaluation or creation category for me.
Gotcha. So maybe if, here's what's happening, and then what would you do next? Might push that up into evaluate, right? Because then conceivably you've got 2 or 3 choices. You've got to kind of judge which one is most appropriate for the given situation. That would bump it up a little bit. Okay. What about understand? I don't understand anything in this question. Right? Create. Someone for create? Yeah.
I thought it was create, only because you have to do all those other things to meet that first.
There's no right answer to this, right? Again, terrible test question I've just asked here, but that's not the point of asking this question, right? I want you to kind of grapple with what these three different things mean. I probably would have put this at kind of apply or analyze, right? I kind of agree with you. Like if he had been asked to like weigh a few options, right? This one, both of these could work, but this one's probably better than that one. Then you're evaluating, you're using some heuristics, some criteria, right? This feels a little bit more like apply, analyze kind of level. But again, context really matters here. So that's the end of our Spock quiz here. My point in sharing this is that it's the same as Tim Steltzer's point years ago when I saw this, is that a lot of the questions that Spock is being asked to show how smart he is are low-level Bloom's questions, right? There's a couple of debatable ones, but a lot of them are remember this, remember that, right? What's the formula for whatever, right? Now, to be fair, when I actually rewatched the video clip, it's actually a memory test. It's pitched as a memory test, right? Because he died and resurrected, so like, is he still the same guy, right? But the impression you get from this is like, man, this guy's so smart, right? He's smart because he remembers things. Sorry, that's like 1980s smart, right? That's not Vision of the Future smart, all right? Again, internet in my pocket, okay? So here's my conclusion from this and my prediction, okay? I think we have adaptive learning systems that are getting really good at teaching this kind of stuff down here, all right? And as they get better over the next few years, they're going to get even better at teaching this kind of stuff down here, all right? They're a long way from teaching that stuff right there. Maybe one day they'll get there, and there's really some interesting stuff with like games and simulations that do move their way up Bloom's taxonomy, so we're going in that direction. But I would argue that if you want, this is more of a prediction than an invention of the future, right? Our job in higher education will be increasingly two things. Either making better systems that teach this, or helping instructors teach that, all right? So this thing, and this came out yesterday in the keynote, right? We've got to start moving up Bloom's taxonomy. We've got to get to create and evaluate in particular and help our students learn how to do that in really robust ways. Okay, I'm going to speed through the last couple of ideas here. This was adaptive learning systems. I want to talk about social pedagogies here for a minute. This is category number 3. Social pedagogies is a term I picked up from Randy Bass at Georgetown. It's these instructional strategies where students have to they construct their knowledge by representing that knowledge for authentic audiences, all right? And Randy likes to say, the instructors are rarely the authentic audiences for our students, right? Their peers can be authentic audiences, and there can be authentic audiences out there in the real world. So a few years ago, I started to see a lot of course blogs, right? Students writing for each other, not kind of Blackboard discussion style, but actually kind of writing for each other live on the open web, right? And sometimes kind of connecting with other audiences beyond that. This is an example from Humberto Garcia, who was at Vanderbilt at the time. And he had a course on Blake. Apparently, there's a lot of crazy people that love Blake online. And he wanted her students to intersect with those conversations online, right? So they started writing about Blake in public so they could do so, right? E-portfolios I would put into this category, right? This is a screenshot from a 2005 e-portfolio, right? It's very 2005, actually, in its web design. The idea, though, is that you've got students doing kind of real interesting work, and they're sharing it in some public fashion with people who actually want to read it and evaluate it and make some sense of it, okay? So more recently, at Vanderbilt, we had the Students as Producers initiative, kind of a theme year at our Center for Teaching. And we started to identify faculty who were teaching courses where students were not being asked to just consume information, but produced knowledge in different ways. And so, particularly at Vanderbilt, it seemed to kind of really resonate as a way to think about what you should be doing in your classes, right? If you're not going to do low-level Blooms, if you're not just going to lecture at your students, what are you going to have them do? You're going to have them produce knowledge in some way, right? So a few quick examples. Elizabeth Meadows over in Women's and Gender Studies in English had our students do a collaborative timeline, right? So they go online to this website called Tiki-Taki, and each student can add multimedia and text elements. Hers was on kind of love and marriage in pop culture over the last 2,000 years, right? Pop culture being defined somewhat broadly in that context, right? And it's this nice little interactive kind of timeline tool, and you can click on different dates and zoom through the ages and pop up images, right? Collectively, her students created this interesting timeline of the history of love and marriage and pop culture, and then she had kind of essay assignments built around that where they had to kind of use that as a tool to make arguments. Right? And here, it's kind of minor, but the students were creating something that did not exist, this particular timeline, right? I don't think there was anything quite like this out there on the web. And then they were also kind of contributing to each other's knowledge in really significant ways, right, as they contributed to this shared resource. Science communication, I would put this in this category. So this was Jeff Johnson in the chemistry department at Vanderbilt. He had his students take one of the nasty, complicated ideas from their organic chemistry class, and they had to create a 2-minute video explaining that concept to like a high school student, right? And so some of these videos were really amazing examples of taking complex ideas and explaining them in really accessible ways to, again, a real authentic audience. Maybe my favorite, Vivian Finch, who actually now works for me. I hired her. She's great. She teaches in the German department. This was an intermediate level German course on the short story, right? So it was an intermediate language course focusing on short stories. She had her students write a collaborative short story in German on Twitter. All right? So each student took on a different role in the story, and they created it over a weekend, one tweet at a time. It was kind of a murder mystery kind of thing. So clever, so clever. Right? They had to figure out what it is to be a German short story first, right? And then take those elements and transpose them over to the Twitter context and make some sense of it. It was just a really deep assignment. The last one I'll share, and you probably know faculty who do this kind of thing too. So Cynthia Cyrus over in our musicology department had her class upgrade this Wikipedia page because it was pretty skimpy, right? They were looking at Brahms. This was a particular opus that he wrote. The Wikipedia page was basically a stub. They spent 3 weeks as a class project researching this opus, learning how to write for Wikipedia both technically and kind of editorially, and then they collaborated and wrote a better Wikipedia page, right? Like, this is real. Like hundreds, maybe thousands of people are going to look at this to learn something about Brahms, right? Her students had a real audience for this work. So again, I'm kind of on speed mode right here, but I want to point out a few principles here, okay? One, if we're going to get students to that upper level of Bloom's taxonomy, right, this is one model for doing it, right? And I kind of focused on tech-heavy examples. You can do some of this without technology, certainly, but this is one good role for technology. You need open-ended problems, right? You need problems that permit kind of solutions that haven't been found or different perspectives in some fashion that haven't been fully articulated, right? We ask this, but if the answers are all known, then it's not going to go in this direction, right? We need some open-ended questions. We need to give students some degree of autonomy. All right, this was my younger daughter's first bicycle. She actually never went very fast on this bicycle, but she felt a great deal of freedom knowing she could hop on and go where she wants to and pedal herself there, right? So our students are we are really motivated when we have a degree of autonomy. We get to pick the topic, the format, the audience, right? Any kind of autonomy we can build into that is going to be motivating for the students because it's going to be more authentic for them as something they really want to pursue. And then finally, this audience piece, right? I took this photo in Boston a few years ago. Here's some guy who's, he's performing for an audience, right? Our students are generally not street performers. Some of them are, maybe. But the work he's doing was actually pretty cool, and it was intended for an audience, right? The audience kind of gives it validity and meaning and motivates him to do what he does. And so connecting our students with authentic audiences, either each other, right? Other students on campus, external audiences. Technology can help us do that, right? So where is this going? Oh, yeah. I'm going to stop right there. This is a terrible example of students as producers. Okay, so this is Hunger Games, right? Katniss has no autonomy in this situation whatsoever. She has been volunteered to fight for her life, right? Let's see, there's not an open-ended situation here, right? 24 kids go into the Thunderdome and 23 of them don't come out, right? It's not called the Thunderdome, that's another movie. Also takes place in the future, right? This is not a good situation. It's not open-ended, right? She turns it into an open-ended problem and breaks that rule, right? And then this is not an authentic audience, right? There's a lot of audience in this clip, but it is not authentic for her, right? These are not people she is trying to please with her fire wings, right? So I was stretching for an example. I couldn't find a positive example of students as producers in the science fiction film genre. Perhaps someone can suggest something later today. But this was the closest I could find as a complete negative example of the kinds of things we want to do. So where might this go? So here's my doodle, all right? So imagine if we got better at helping students share their interesting work with authentic audiences. Imagine we had something like your sites here, all right? A WordPress platform or something, where students can contribute blog posts and videos and essays and photos, right? Courses can be organized, right, to kind of collect information from students. If you run the kind of, you guys this huge kind of complex WordPress system kind of thing where students are contributing in a public fashion in all kinds of interesting ways, right? And if you read it this way, you have e-portfolios, right? Damn it, they're still cool. E-portfolios sounds like such a 1999 kind of thing, but like they so work, right? It's such a good technology. You read it the other way, you have course blogs, right? You have this whole thing searchable so you can find kind of connections around campus, right? This student over here figures out there's another student on the other side of campus who's studying something similar in a different class, right? And they make that connection. I want this kind of thing, right? This is what I want my course management system to look like. I want it to do this, right? Let's invent that. Okay, I am over time, and you guys need a break. 2 of you just left anyway without me saying this, so I'm going to stop here. Let me close your eyes real quick, okay? Prezi can be a little bit confusing if you move too fast, and I'm going to move fast here for a second. Number 4 was learning spaces. Punchline, these things need to be movable, all right? Okay? I see a trend towards more flexible, active learning spaces, and we can talk more about that after break if you want. Here's what I want. Okay, so we've got these leading lines, right? Classroom response systems, adaptive learning systems, social pedagogy. Something's going to happen to our learning spaces. Where is this all going? After break, I want you to help me imagine that, all right? So be back here in about 10 minutes. Sound good? Great, see you there.